Hi everyone. Today we will discuss sum and difference identities of trigonometry. For example, sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta, like that. And this identity is very useful and important, especially when you try to find some exact value of trigonometry, especially when your angle is not special angle, but your angle can be expressed by sum or difference of two special angles. Okay, let me explain this picture first. Here you have a hypotenuse here, adjacent to here, opposite here, and angle is theta. We already know that y over h will be sine theta, right? And from this equation we can find the value of h. The length of opposite will be hypotenuse times sine theta. Okay? And one more things, x over h equals cosine theta by definition, right? So from here x will be h times cosine theta. Okay, this two equation is very useful to find opposite length or adjacent length when you are given hypotenuse and angle. Okay, remember this one. Now look at the left side picture. I have a square, and inside a right triangle is inscribed, and to make the question simple, I make hypotenuse is 1 here, and two angle alpha and beta. Okay, I will erase this one. Okay, first please focus this right triangle. In here we have a hypotenuse and angle, right? So by this I hope you can find the opposite and adjacent. Opposite is a hypotenuse times sine theta, so this will be sine alpha, right? You don't need to copy 1 because hypotenuse is just 1. And with the same reason, this is the cosine alpha. It's okay? Now this times, please focus this triangle. Again, you are given the hypotenuse and the angle of beta here. So with the same reason of this, what is the opposite? Hypotenuse times sine theta, in this case beta, right? And what is the adjacent? Hypotenuse times cosine beta. Okay, this is here and this is here. Good. Okay, I will think one more angle, this one. Can you see small right triangle? Oh, when this is beta, with a very simple geometric knowledge, this is 90 degree minus beta, this is 90, so this one is also beta. Okay, can you see the small letter beta? Now in this small triangle we have a hypotenuse, which is a sine alpha. Now what is this? Hypotenuse and sine theta. of sine beta. Is okay? Now how about adjacent hypotenuse times cosine theta, in this case cosine beta. Is okay? Okay, good. Now I will sketch you one more triangle. I will use this color. Can you see this triangle? In this case, the angle is alpha plus beta and the hypotenuse is 1. So what is the sine alpha plus beta? Sine is opposite over hypotenuse. In this case, hypotenuse is 1, so you can simply try to find length of this one, right? But unfortunately, we don't have any label for this one, but we have these two things. Definitely sum of these two value will be the opposite of the triangle. So I hope you can write sum of these two things is sine alpha times cosine beta plus cosine alpha sine beta. Okay, this is our first sum identity. In this case, only sum. And if we have a negative sign between two angles, this is a negative value. Okay. Now, with the same picture, we will discuss cosine value. So cosine alpha plus beta. Again, please focus the same triangle here. In the case cosine is adjacent over hypotenuse, again hypotenuse is 1, so you can simply try to find this one. Okay, adjacent. Again, unfortunately, we don't have any adjacent length on this picture, but we have this long side and this is short side. So judging from the picture, by simply subtracting the shorter one from the longer one, that will be the adjacent of the triangle, right? So is it okay to write cosine alpha cosine beta minus, not plus, sine alpha sine beta? Okay, when you have a negative sign here, very interesting, we have a positive sign here. Okay, so this is the sum and difference identity of sine and cosine. Okay, one more, tangent. If you have a tangent alpha plus beta, by definition, tangent is the sine of cosine, so sine alpha plus beta over cosine alpha plus beta, right? And we can use these two information. So sine alpha plus beta will be sine alpha cosine beta plus cosine alpha sine beta, and the denominator cosine alpha cosine beta minus sine alpha sine beta. Okay, now for simplicity, I will divide the numerator and denominator by cosine alpha cosine beta, cosine alpha, cosine beta. Then we have a very interesting result. When you divide this one by distributive property, please note that cosine beta will be cancelled out. So you have only sine alpha over cosine alpha, right? And when you divide this one by cosine alpha, cosine beta, in the case cosine alpha will be cancelled out, so you have only sine beta over cosine beta. Okay? And when you divide this one by this one, please note that they have the exactly same expression, so you have only one left. And this divided by this, no cancellation, you have a sine alpha, cosine alpha times sine beta over cosine beta. Okay? Now, one more step. By definition, sine over cosine is tangent. So this is the tangent alpha plus tangent beta 1 minus tan alpha tan beta. Okay? If you have a negative sign, this will be negative, this will be positive. Okay? So let me back to the original equation. Now we proved why we have these 6 sum and difference identities. This is a really fundamental formula or identity. Without this, we cannot proceed the more advanced trigonometry. So please invest some time to memorize this one. Now, what is the uses of this identity? Here, sine 75 degree. Wow, 75 is not special angle, but we can rewrite this one as a sum of 2 special angle, right? 45 degree plus 30 degree. So this is not sine 45 plus sine 30. We must use the sum identity, which is sine 45 degree times cosine 30 plus cosine 45 degree times sine 30 degree. Okay? Now, I hope you remember the value of a special triangle. Sine 45 degree, 1 over that equal 2, or 1 equal 2 over 2. Cosine 30, radical 3 over 2. Cosine 45, radical 2 over 2. Sine 30, 1/2. Now we have the same denominator for numerator, radical 6 plus radical 2. Okay? When you have a direction of find the exact value, in most cases this implies no calculator. Okay? How about the next question? Cosine 105 degree. Again, cosine 105 is not special angle, but you can rewrite this one as a cosine 60 plus 45. In here, 60 and 45 are both a special triangle. I hope you will remember the sine or cosine value of 60 and 45. Let me use the identity first. Cosine 60 times cosine 45 degree minus sine 60 times sine 45 degree, right? Cosine 60 is 1/2, and cosine 45 is 1 over radical 2 or radical 2 over 2. sine 60 equals radical 3 over 2. Sine 45 is again radical 2 over 2. So you have a radical 2 minus radical 6 over 4. Okay. Okay, one more question. Tangent to 15 degree. Again, 15 is not special angle, but 15 can be 45 degree minus 30 degree, which are both a special triangle. If I use the sum and difference identity for tangent, this will be tangent 45 degree minus tangent 30 degree, 1 plus tangent 45 degree times tangent 30 degree. It's okay? Now tangent 45 is 1, tangent 30 is 1 over radical 3, so 1 plus tangent 45, which is 1, times tangent 30, which is here, right? To simplify the complex fraction, you can multiply by radical 3 to the numerator and denominator. Then you have a radical 3 minus 1, radical 3 plus 1. Okay? Let me review this sum and difference identity one more time with the different variable. For example, A and B. Then sine A plus B will be sine A cosine B plus cosine A sine B. When you have a negative sign here, you must have a negative sign here. And cosine A plus B will be cosine A times cosine B minus sine A times sine B. When you have a negative sign, you must have a positive sign here. And third one, tangent A plus B will be tangent A plus tangent B over 1 minus tangent A times tangent B. When you have a negative sign, you must have a negative sign here, and you must have positive sign here. Okay? So please invest some time to memorize these 6 identities. Okay? Okay, thank you very much for watching. Bye-bye.